Let's look at this problem. For any positive integer m, the notation m factorial, so this is called factorial with the exclamation sign. M factorial denotes the product of the integers 1 through m. What is the largest integer n for which 5 to the nth power is a factor of this expression? Alright, this problem is about a factor. Okay, so we want to factorize this expression. So let's give it a try. Actually, this expression is fairly nice because 98 factorial is you multiply from 1 to 2 to 3 to 5 to 4 to 5 and so on and so forth till 98. Therefore, they have lots of common factors. So let's write it out. 98 factorial plus 99 factorial plus 100 factorial. Now let's see how it looks after the factorization. So we certainly know that the first number itself is a factor of all the remaining two numbers. So we factor it out and multiply 1 plus 99 is what's left, plus 99 times 100. Right? So let's leave the first factor as it is. And let's look at these brackets. So what do we get? We can combine the first two and we'll get 100, right? We'll get 100, we'll get a 99 times 100. Good. So this equals to 98 factorial times 100. And after we factorize this 100 out, we have a 1 plus 99 left. Therefore, we have another 100. So let's put it 100 square. Good. So now we need to find the largest n so that 5 to n is a factor of this. Good. So let's look at it from the easiest term. So this is certainly easier than this one, right? So for 100, we know that for 100, so we know that 25, which is 5 square, is certainly a factor of 100, right? So is 5 cube a factor of 100? No, 5 cube is 125. Therefore, we'll get 2 exponent for the 5 from each 100. So we have 2 hundreds, right? It's because it's 100 square. Therefore, this one contributes 2 by 2 exponents for the power of 5. So we have so much from the second term, 100 square. How about the first term? The first term is a multiplication of many, many numbers from 1 all the way to 98. So the best way to do that is to find the patterns, right? So what's the best way to find the patterns? So as to a multiple of 5, we know that we have a multiple of 5 every 5 numbers. For example, from 1 to 5, we have a 5. That's a multiple of 5. And then from 6 to 10, we have another multiple of 5, which is 10. Therefore, from 1, 2, 3, all the way to 98. So how many such 5 numbers group do we have? So we have 98 divided by 5. So that's 19. And with a remainder, right? We don't care about the remainder because the last multiple of 5 will be 95. So the remaining 96, 97, 98 doesn't matter. Therefore, we have 19. We have 19 more multiples of 5. So, are we done here? We are not done yet. because we did the calculation or the count of multiples of 5, but look at this. There are also multiples of 25. For example, 100 itself is a multiple of 25, right? So are there any other multiples of 25 less than 100? Of course there are some, right? But for those numbers, they provide more power to the 5 exponent, right? For example, 25. 25 equals to 5 squared. It supplies 2 exponent, not just 1. In this number 19, we only counted once. Therefore, we need to plus 1 from 25. And we have another multiple of 25, which is 50, right? So that equals to 2 times 5 squared. So that supply another one exponent. And how about 75, right? It's 3 times 5 squared. So we have another one. And do we have any more multiples of 5 or multiples of 25? Or maybe multiples of 5 cubed? No, we have nothing else, because we've counted all multiples of 5, multiples of 25, but multiples of 5 cubed is greater than 100. So we certainly don't have any of such numbers. Therefore, what's the largest exponent we can get for this n? What is the largest exponent? So we have 2 by 2, 19, and we have a 3 here. Therefore, the largest n we can get is 2 by 2 plus 19 plus 3. So this is 4 plus 19 plus 3, right? So this is 23 plus 3, that's 26. So the answer is D. That's our choice. If you like this video, please subscribe and thumb up. If you have questions, please comment.